Cleaned up a bit in the storage room and found a window pane, a piece of chipboard and some joists. I thought about all the videos I've seen about solar air heaters that haven't given me the answers I want. Everyone shows the temp of the air coming out, but rarely the data of dimensions, airspeed and temp in. So now I'm building my own and making sure I get answers to all my questions. I built the frame with 2x3 and used a plunge-cut circular saw for the notch that the window sits in. I used the 2x2 channel walls for the air to move through. Filmed from the backside. The depth of the notch for the window is 0.5 centimeters, 1/5 of an inch. The chipboard on the back is held in place with screws. The chipboard was there as protection at the bottom of a pallet, so I saved it for a suitable project, like this one. The back, frame and window are now in place. I put the walls alternately with 10 centimeters for inch intervals for the air to move. The total air duct contains a total of 26,055 cubic centimeters or 0.026 cubic meters of air. Cut to pieces to the correct length, which I then used as a template for the correct measurements. With the templates in place, I laid out all the walls at the correct distance and drew the outlines with a pencil. Pre-drilled 3 holes for each wall piece to make it easier to find the right one from the back. The screw holes were countersink from the back, so that the screw head is flush with the surface. Placed all the walls and screwed them in from the back. Used a 20 millimeters, 25/32 inch center bore flat and drilled for holes for connecting the hoses under the pool. For the fan I used a 73 millimeters to 0.87 inch hole saw. The fan is a brushless, 12 volts radial fan that will be powered directly by a suitable solar panel. Now it is connected to a small 5-watt panel. Let's see if it will be too small, or maybe even too big. A small shadow test, where the fan should only spin when the sun is shining. Ready to test. Tried placing some thermometers in the ducts, but got very different results from them. 149 degrees Fahrenheit, 65 degrees Celsius. Due to the heat, several of them stopped working pretty quickly, so a new plan for temperature reading is needed. According to this thermometer in the air hose out, I have 31 degrees Celsius, 88 degrees Fahrenheit out. The air in is 14 degrees Celsius, 57 degrees Fahrenheit. I'm happy with that test result, so now it's painted black. Smoke test number 1. I didn't have a smoke cartridge, so I had to make my own. The camera has trouble capturing how the smoke moves in the ducts, so smoke test number 1 was a fail. I need more smoke. I used to homemade smoke cartridges in smoke test number 2. This time the camera angle and the sky were adjusted so that the smoke wasn't visible anyway. Smoke test number 3. 4 pieces of smoke cartridges. Here we go. Success, but areas of turbulence appear quite immediately. I'll have to try to round off the turns in the canal somehow. Back to the drawing board. The homemade smoke cartridges were a little too effective, so the test had to be stopped. Behind the 5 post-it notes, there is a temperature sensor. The outdoor temperature is 21 degrees Celsius, 70 degrees Fahrenheit. However, I don't understand why the temperature increase stops from temp number 3 and up. We move on to airspeed. The 5-watt panel that drives the fan now gives about 5.4 meters per second. I let it run for 10 minutes before this test. I can now adjust the fan speed with a speed controller. At its slowest, this fan blows 1.6 meters per second. In this wind test, I increase the speed every 3 minutes, see how the thermometers react. Okay, 3 minutes in, and the thermometers have barely moved. We increase the fan speed to 2.5 meters per second. Okay, 6 minutes in, and the air out has increased plus 1.7 degrees Celsius plus 3 degrees Fahrenheit with the slightly higher fan speed. We increase the fan speed to 3.0 meters per second. Okay, 9 minutes in, and the air out has increased plus 0.9 degrees Celsius, plus 1.6 degrees Fahrenheit with the slightly higher fan speed. Still don't understand why the temperature doesn't increase from half the solar collector. We increase the fan speed to 4.0 meters per second. Okay, 12 minutes in, and now it's happening a bit more with the temperature rising by plus 3.3 degrees Celsius, plus 6 degrees Fahrenheit at 4.0 meters per second. We increase the fan speed to 5.0 meters per second. Okay, 15 minutes in, and now the temp rose by +13 degrees Celsius to 0.3 degrees Fahrenheit at 5.0 meters per second. We increased the fan speed to the maximum, 6.1 meters per second. Okay, 18 minutes in, and now the temperature has dropped by -0.2 degrees Celsius, -0.4 degrees Fahrenheit at 6.1 meters per second. The temperature sensors in the solar collector are positioned according to the numbers 1 to 5. I expected to get completely different measurement results depending on different airspeeds. Considering the temperature coming out, the airspeed should be between 5 and 6 meters per second. So the small 5-watt panel that produces 5.4 meters per second will probably be perfect for the task. Still wondering why the temperature approximately reaches maximum, already at temperature sensor 3. New plan, I'll split it in half, and make a 2-in-1 instead, see if I can get to by 58 degrees Celsius, 137 degrees Fahrenheit out, on the same surface area. It is now divided into 2 separate ones, and both fans are in place. The silicone ring I use as a gasket is actually for a jam jar. Perfect size for the fan. Temperature sensors 1 to 5, inserted from the back. Overview of the lower part with temperature sensors. Overview of the upper part with temperature sensors. Here it is, divided into two separate solar air heaters. I'm really hoping for dual outlets of 60 degrees Celsius, 140 degrees Fahrenheit hot air that I can blow in the 4 flex hoses under the pool. Side-by-side comparison of single output, double outputs with temperature differences. I replaced the 5-watt panel with two 10-watt flat panels instead, 21.7 volts, 0.45 amps. They are connected directly to the fan with homemade buck converters that output 13.4 volts. Perfect, the double one gives pretty much the same results as the single one on the same surface area. This is the idea I came up with to counteract the turbulence we saw in the smoke test. I used around 10 centimeters per inch plastic ventilation pipe divided into 4 parts for these corner pieces. Will be a new smoke test to see if it works according to plan. Now there are 20 millimeters, 90-degree bends on the flex hoses that run under the pool. You can check out this video if you want to know more about the flex hoses. Here I am testing with 2 thermometers, one in the fan and one in the hose. The Y coupling and the flexible hose, 1 meter, 3 feet long, are made of PVC and lack insulation. But the heat loss is remarkable, minus 15.3 degrees Celsius, minus 27 degrees Fahrenheit. It immediately makes me think about how far the warm air reaches under the pool until the air reaches the temperature of the water. And also, how will I succeed in measuring it? I'm testing 2 different Y connectors, let's see which one works best. To avoid heat loss, I'm going to insulate almost the entire backside. Smoke test number 4. I don't have much knowledge about turbulence, but if you do, please leave a tip in the comments. Another problem that I hadn't thought of. Since the idea was to mount it vertically at a 90-degree angle to the pool, there will of course be shade in the channels. And there's a lot of shade, like 30% less surface area to catch the sun's rays. The difference in temperature of the air out, shade in the ducts versus no shade. The solution: skip the rounded corners and bevel all the walls in the channels at the appropriate angle. But that will be in part 2 of this project, and then also with measurements of the air temperature under the pool. Thanks for watching part 1 of this project. And remember to like and subscribe to let other like-minded find my channel.